All right, in 10.3, we're going to look at quadratic applications. This is getting you ready for AP thinking, for AP calculus, higher level thinking with quadratic applications. So let's try this out. You'll see it's not so bad. You're standing at the baseline of a tennis court and you want to practice your soccer skills. You want to kick the soccer ball from one baseline to the other, which is 78 feet away. But at the same time, only clear the 3-foot net by 1 foot. The ball will travel in a parabolic path with the highest point being 1 foot above the net. So the first thing you need to do always is draw a picture and label the points. All right, so here's my straight line. Here's my starting point. So that's point 0, 0. It says it goes in a parabolic path. So that means a parabola. So it's going to make a curve. And it says it clears the distance that's 78 feet away. So my x value is 78 and y is 0. It says you want to kick the ball, clear the 3-foot net by 1 foot. So up here, the peak, 3 foot by 1 foot means it's going up to y equals 4. So 3 plus 1 is 4. Now, as far as this, well, let's think. This would be halfway through, right? So 78 divided by 2 gives me 39. So 39 is my x-coordinate. My y-coordinate is 4 when I'm doing this. All right? Now, what do we do next? Well, it says define a reasonable domain and range using set notation. So I want to think about this because I need to put this in my calculator eventually and think about what are my x-coordinates. Well, they go from 0 to 78, right? So you don't always want to set it equal to 78. Make it a little bit bigger so you can see really what's going on. But x is between these two values, so it's going to be 0. X is between, it can be equal to, and I would make it up to 80 just for fun so we make sure we see that point. Now, the range, the y values, where would my y values be between? Well, it's between 0 and 4, right? But I would bump it up a little bit just for fun because you want to be able to see the peak. You don't want to stop right there at 4. All right, so make yourself a note. When you do this, right now we're doing set notation, and when you do this, you want to go outside the picture so that it will show up on your calculator. It's like you want to give it a little bit of margin in the top, the bottom, left, and the right. That's why we go a little bit further on these values. All right. Now it says write an equation in vertex form relating the height of the ball to the distance traveled. The height of the ball to the distance traveled. So remember the equation for in vertex form looks like this: a times x minus h squared plus k. Okay, this is what we're going for. Now, we know our vertex is at 39, 4. So this is my h and this is my k. Now, what point would I use? Well, I would use the easiest point possible. I would use the 0, 0. So there's my x and my y. Now let's look at this. Let's plug in our values. So we would have 0 equals, a is the unknown, so leave it there, 0 minus 39 squared plus k. Now, I want you to see something on your calculator. So hopefully you know for a fact that any negative number squared is always positive, right? Well, look what happens in your calculator. If I put negative 39 and I square it, it comes out negative. That's not correct. All right, the only way the calculator is going to get it right is if you put this in and then it comes out positive. So how do you get around that? Well, maybe you just put in 39 and you square it because you know it's going to come out positive. Whatever you need to do. 1521a, but don't ever write it negative because it's not going to be negative. All right, plus 4. Now we're solving for a, so I'm going to move my 4 over. Becomes negative. Divide by 1521. So that means the a value is negative 4 over 1521. Now you're like, well, does that reduce? I don't know. Here's a way to find out. If you put this in your calculator, alpha y equals put in -4 over 1521, and you hit enter, it will reduce it automatically. So since it didn't change, that just tells me that it's in the simplest form already. So there's A. Now I can write my full-on equation. So now I know I'm going to put A in as -4 over 1521, x minus h, don't forget to square it, plus k. So there's my equation. Now, is the vertex a minimum or a maximum? If I look at this, that's the maximum y value, so it has to be a maximum. All right, on part E, list the transformations in regard to the parent functions. This is back what we were doing in Unit 6, where we listed what's happening to our equation. What are each of these parameters doing to the original? So let's look at these. So the first thing I notice is the negative. The negative means it's a vertical reflection. You could also say reflect over the x-axis. That works as well. Then I notice that this is a fraction, which means it's vertically shrinking. The -39 means it's moving to the right 39 units. And the +4 is up 4. Now, I want to show you how this looks in your calculator, how we're going to do all this business in your calculator. So obviously, we're going to have to know our equation to put it in, right? So let's go into our y equals and clear out whatever might be in there. And I'm going to type in this equation that we found. All right, so alpha y equals -4 over 1521 times x minus 39 squared plus 4. All right, now as is, if I graph that, I'm really not going to see a whole lot going on, right? Because I know that my window is not what I need it to be. That's why we did this step right here. So the way you're going to adjust is you're going to go to Window, and you're going to change your x minimum to 0, your x maximum to 80. You can scale it. I would scale it by 5s or 10s or something really easy to see. Or you can take 1/10 of whatever you have, so it's like 10 little tick marks. But I'm going to do it by 10s just for ease of measure. For y minimum and maximum, that's what we decided here. The minimum is 0, the maximum is 6. You can scale it by 1, that's perfectly fine. Now let's look at this. Now it looks like our picture, right? And now if we wanted to find the maximum of this, just to double check our picture, or we can hit second calc, and let's find the maximum. So we're going to do a left boundary for the max, right boundary for the max, remember the little triangles, hit enter again, and there it is. So 38.99999, pretty much 39, and then 4. So we found our maximum. So there we have it. There's our graph. Our window worked just fine. Now, if you need to go back to the generic 10 by 10 window, remember it's just zoom and 6. So that set us up for the next problem. Let's try another one. The main cables of a suspension bridge are 50 feet above the road at the towers and 10 feet above the road at the center. The bridge is 200 feet long. Vertical cables are placed every 20 feet. The main cables hang in the shape of a parabola. So here's my bridge. You see how it's a parabola? It's opening this way. So I need to visualize what's happening. So I'm going to draw my parabola this way. And we need to figure out what are our x and y coordinates there, and what's it going to be at, looks like a minimum, right? The lowest y value. So if we start here, 0, it says the bridge is 50 feet above the road. So we know the y value is 50. Okay? And it says the bridge is 200 feet long. So that means this distance right here is 200. So it's 250 right over here. Then it says, and 10 feet above the road at the center. So this is above the road at the center means that it's 10 feet above the road. That's my y. Now, it's halfway across the distance, so that means it's 100. Now we have our key points. Now it says describe a reasonable domain and range. So now notice this one says use interval notation. So I'm going to, my lowest x value is 0, the highest is 200, so I'm going to bump it up to like 220. And I'm going to use brackets because it does equal 0 and potentially 220 on my window. The range, okay, what's the lowest? Well, I'm going to make my lowest 0, even though it's 10. I'm going to make it 0 just to have a window. And the highest, it goes up to 50, but I'm going to bump that a little bit to 60 so I can see my full window. Now we're going to write our equation that relates to the height of the cables to the length of the bridge. So again, let's think. What is our vertex? It's at 110, so that's my H and my K. My point, easiest point to pick is the origin or the original point of my drawing, so 0, 50. This is my X and my Y. Remember, the equation looks like this. A times X minus H squared plus K. So we're solving for A. So I'm going to have 50 equals A times X minus H squared plus K. Now let's clean it up. Alright, this is going to be negative 100 squared, which makes it positive, right? And it's going to be 10,000 A plus 10 equals 50. I'm just going to move it over here. Move my 10. 10,000 A equals 40. Obviously, I'm going to have to divide by 10,000. When that reduces, if you don't want to do it by hand, remember I showed you that thing where if you put it in your calculator, you go alpha y equals, put it in as your fraction, it reduces it for you. So there's 1 over 250. Now, there's my A value. So my equation, let's go back and rewrite our equations. 1 over 250, X minus 100 squared plus K. There's my equation I'm going to ultimately put in my calculator and check. Is the vertex a max or a min? Well, look, it's going down, so that's a minimum. Then it says part E, it says how high is the third cable? Okay, well the third cable, let's think on our x-axis. If it starts at 0, it says the cables up here are every 20 feet. So the first cable's at 20, second cable's at 40, third cable's at 60. So my x value is 60. That means I need to find out where x is 60, what is my y value? So let's put this in our calculator instead of doing it algebraically. Let's put it in our calculator and find out. All right, clear out what we had. Let's put in our new equation. All right, 1 over 250 x minus 100, square it, plus 10. All right, it's in there. Now we need to change the window. Let's change our window. X minimum is going to be 0. This is going to go to 20. I'm going to do it by, I don't know, 20s, 30s. I'll do it by 40s. As long as we have basic tick marks. Y minimum is 0. Maximum is 60. So I'm going to keep my scale at like 1/10 of 60 is 6. That works perfect. And then I can hit graph and I should see my bridge come up. Alright, there it is. Now, if I hit trace, just trace this gray button right here, hit trace, it's gonna like trace me along the right, along the parabola, right? Well, I really don't want to have to look and see where is it exactly 60. So what you don't know is that you can just type in 60 for x and it's going to bump you right where you want to be. So that means that the y value is 82 over 5. Well, that does not put it in the context. That's feet. We need feet above the ground, right? So we would never say 82 divided by 5. So let's put this in our calculator, hit second and quit. Let's put 82 divided by 5 in there, and that makes more sense. 16.4 feet above the ground. So you always want to put the correct units on it. All right, so let me refresh your memory. What did we do? We went to trace and then put in the x value we wanted. And that gave us the y. Okay? All right, I hope this lesson makes sense to you, and we will deal with any questions you have in class.